We need to show that the diagonals of a rhombus are perpendicular to each other. Okay, let's begin. So here we have the Cartesian plane with the x and the y axis, and we are choosing a rhombus. Let's name it OABC in such a way such that one of the side OA lies along the x-axis. Now here we can define the coordinates of the vertices of the rhombus. So we'll start with the vertex O. So since at the origin its coordinates are going to be 0, 0. Then A, we can specify its coordinate as x1, 0. There is no y coordinate here. We're going to define the coordinates of C as x2, y2. However, in order to find out the coordinates of B, we'll have to do some construction here. So let us drop two perpendiculars from point C and point B on the x-axis. So from point C, we drop a perpendicular on the x-axis and let it named CM. And we have BN, which is perpendicular on the x-axis as well. Now, since it's a rhombus, clearly the sides are going to be equal. So that means OA is going to be equals to AB. This will be equals to BC equals to CO for the rhombus. All the sides of a rhombus are equal. Now, since CM, that's going to be the height of the rhombus, which is y2. So that means the height of BN is also going to be y2. So that means the y coordinate of B2, that's going to be y2 as well. Now we'll have to find out the x coordinate. Now, clearly here OM must be equals to AN. This length must be equal. Now since OM, we have already defined that OM, that is x2. This implies that the length of AN must be also x2. Which means that coordinate of point B, what's coordinate of point B? So that's OA plus AN, which is nothing but from here to here we have x1, AN, so that's x2. So that means coordinate of B is going to be x1 plus x2. Fine. Now let's do one thing. Let's join the diagonals of the rhombus. So here in the diagram, we can see that the two diagonals of the rhombus OB and CA, they intersect each other at D. Now, it's a property of a rhombus. We know that the diagonals of a rhombus bisects each other. Well, let's write it down. So diagonals OB and AC bisects each other. So if they're bisecting each other, then it's clear that OD, the length of OD must be equals to length of DB, or we can say that length of CD must be equals to length of DA. Or we can either way, we can say that D is the midpoint of OB, or we can say it's the midpoint of CA. Fine. So we're going to use the midpoint of OB, so that can be used to find out the coordinate of D. So let's find out the coordinate of D. Coordinate of point D. So that's going to be, so we're going to use the midpoint formula. So we take the endpoints, which is A and C, sum of the x coordinates. So that's x1 plus x2 divided by 2. And to find out the y coordinate, we take the sum. So y2 plus 0 will be simply y2 over 2. So now we have the coordinate of point D. Now since we need to show that the diagonals are perpendicular to each other, we will show that ODA is a right angle triangle. So that means it's right angled at D. Fine. Now what we'll do, we'll try to find out the length of OD, DA and OA using the distance formula. Fine. So let's begin by first finding out the length OD. So ODs will be simply equals to, we'll have to take the square root. Underneath the square root, what we need is the difference of the x coordinate. So since the x coordinate of D, that's x1 plus x2 over 2, from here we're going to subtract the x coordinate of O. Now since it's at the origin, so it will be simply 0. Square it and then add it to the difference of the y coordinate. So that means we have y2 over 2 minus 0 whole square. So let's open it up. So this is going to give us square root of x1 plus x2. So this is x2 divided by 2 whole squared added to y2 over 2 whole squared. So that's the length OD. Now let's try to find out the length DA. So DA is going to be equals to, so we have to take the square root underneath the square root. So we'll have to take the difference of the x coordinate first. So we'll take the x coordinate of D. So that's x1 plus x2 divided by 2. And from here we subtract the x coordinate of A. So that's x1. We square it and then add it to the difference of the y coordinate. So that's y2 over 2 minus 0 whole square. So let's simplify this, and this is going to give us that we were going to get square root of x2 minus x1 over 2 whole squared added to y2 over 2 whole square. And then we'll find out the length OA. So OA is going to be, we'll take the square root, underneath the square root we have x1 minus 0 whole squared plus 0 squared, so that simply equals to x1. Okay, now since we want to show that ODA is a right angle triangle which is right angle to D, so we'll use the Pythagoras theorem to show that OA squared must be equals to OD squared plus DA squared. So we have to show that OA squared must be equals to OD squared plus DA squared. Fine. So what's OA squared? OA squared, that will be x1 squared. And now we have to use the value OD squared. So this is the OD squared value. So we have x1 plus x2 over 2 whole squared added to y2 over 2 whole squared. Then we add it to dA squared. So that's x2 minus x1 over 2 whole squared plus y2 over 2 whole squared. Okay, so let's solve the right hand side. So we have x1 squared plus x2 squared plus 2 times x1 times x2 divided by 4 added to y2 squared divided by 4 plus we have x2 squared minus 2 times x2 times x1 plus x1 squared divided by 4 plus y2 squared over 4. So we have a common denominator of 4. So let's take the common denominator and add up all the terms in the numerator. So we have x1 squared plus x2 squared plus 2 times x1 times x2 plus y2 squared plus x2 squared minus 2 times x2 times x1 plus x1 squared added to y2 squared. So here we can cancel out 2 times x1, x2, and then we add up the terms. So we have 2 times x1 squared plus 2 times x2 squared plus 2 times y2 squared all divided by 4. So this will be equals to x1 squared plus x2 squared plus y2 squared divided by 2. Now we have obtained this expression x1 squared plus x2 squared plus y2 squared over 2, whereas on the left hand side we obtained the expression x1 squared. Fine. Now since we have the rhombus OABC, since OBC is a rhombus, that would mean that the sides are equal. We all know of this. So OA must be equals to OC. Now we have defined the value of OA. So if we use, so let's square it. So OA squared will be equals to OC squared. If we use the distance formula, so this is going to be x1 minus 0 whole squared plus 0 minus 0 whole squared. So that's the length of OA, and OC is going to be x2 minus 0 squared plus y2 minus 0 squared. So that is going to be x1 squared equals to x2 squared plus y2 squared. So that means we can replace the value of x2 squared plus y2 squared with x1 squared. So which we'll do in this particular case, we are going to replace x2 squared plus y2 squared with x1 squared, such that we now get on the left hand side we have x1 squared, on the right hand side we have x1 squared plus x1 squared divided by 2, and this is nothing but x1 squared. Hence we have successfully showed that the square of OA squared is exactly equals to the sum of the squares of OD squared and DA squared. So that means ODA is a right angled triangle. So we have successfully showed that OD is a right angled triangle, which means that we can say that OB is perpendicular to OAC. This implies OD is perpendicular to AC, and we can finally say therefore, or we can say thus, the diagonals of a rhombus are perpendicular to each other. Hence proved.